YouTube. Alright, so we're going to be stepping through Leetcode 141 linked list cycle. Given a linked list, determine if it has a cycle in it. Basically, we're just stepping through a linked list data structure and checking if the nodes point back to each other in an endless cycle for eternity and forever until the heat death of the universe. And if it does, we'll return true. For our example 2, we will return true because it's the same thing, it's just a giant circle. And then for 1, doesn't point anywhere. So our output is false. So a couple of prerequisite knowledge I guess you have to have before you can implement our solution. Just using use strict in JavaScript meant to help catch bugs. You have to know what objects are in JavaScript. Conceptually, they're just hash tables if you have like a computer science background. If you don't, it's just a data structure with a key value pair. So we have our object, and then object key 1 is value 1, key 2 is value 2, key 3 value 3. It's going to look like this, where it's going to be key 1, value 1, key 2, value 2. Our object will look like this. However, nodes, or these things, which are called values in linked lists, are all basically objects. It's just the object data structure. So, for example, our first example 1, it looks something like value 3, and then our next value would be value 2. And so I'll run this file after we're done here, and you guys can see what the executed code will actually look like. And then we have recursion. So recursion is a function that calls itself iteratively. And if someone tries to teach you recursion through Fibonacci, you should not treat them very nicely. So what we're gonna do is we have this array, and we're just going to loop over it. This is going to be a for loop, this would be a while loop, and then we'll do it recursively. So our for loop is pretty straightforward. For our index I, while I is less than the length of this array, we're going to increment I, and then we console log our element, our index, and then we'll just say for loop, and then this will also be I for our index. While I is less than the length of the array, we'll console log the element, the index, and we'll just call it while loop while going through. And this is just going to print things to the terminal. This is just print things out. And so this is our recursion, where it's a function that calls itself. We declare it recursion, we pass in an array, and then we also pass in our index as a parameter. And so if our I equals the length of this array, we'll return. It's basically what we're doing here, and then what we're doing here, and then we'll console log the element, the index, and then we'll just call it recursion so you can see that. And so we call recursion and the array, then index plus equals 1, which is just incrementing, and then we'll get the exact same thing for all 3 of these outputs. And so this is the last bit of prerequisite knowledge. Is linked list data structure, which is basically a linear collection of data elements. We're just going to be going over singly linked lists in this video, which is basically one element that points to a next element that points to a next element that doesn't point to anything. So this is creating the nodes, which are objects. This is linking the nodes. So A, the next node from A is B, right? A.next equals B, B.next equals C, C.next equals null. A points to B points to C points to nothing. And then we'll just console log the nodes so you can kind of see them as they come out. And this is putting everything together. As far, me personally, I just think recursion is a lot easier to implement for linked list data structures, so we're just going to go with it. It's the same thing, declaring our solution, we're passing in a node. If there is no node, this is a not operator, we'll just kick out of our function call. We'll console.log node.val, and then solution, call it again, and just pass in node.next. So we'll just recursively stepping through our first one. We won't have to go to the example. We pass in A, right? If there is no node, we will return, but there is a node. So we're going to console.log the value, which is 1, and then we're going to go next. And console.log the value, which is 2, and then go next. And then console.log the value, or print out 3, and then go next. And now there is no node, so we just return. We stop going. This is important in recursion because this is how we stop looping forever, or just constantly calling back to the function and trying to, we end up with Stack Overflow if we don't have our kickout. So this is usually the first parameter you want to write. And then this is our solution, and this is the printout. So we can run it. And this is our object, right? We have key, value, key, value, key, value. This is our array. This is iterating through it with our for loop. This is printing out the elements. And then this is the iteration starting from 0, 1, 2, 3, 4. Elements, iteration, and then recursion. Elements, iteration, right? This is our linked list. And we have our value, which points to next. Value, which points to next. Value points to next, which is null. This is A, this is B, this is C. And then we're just printing out the values here, right? Pretty straightforward. And so we can step through our example 1. And let me just make sure I went too far. Ignore this. I guess. I'm not going to edit this video. I'm way too lazy. So we'll just do it this way. And then we have A, B, C, and D. So this is our very first example. We have A, B, C, and D. A's value is 3. B's value is 2. C's value is 0. D's value is -4. A.next is B. B.next is C. C.next is D. D.next is B. And they're all just pointing one way. And then it goes back, and they just keep going in a circle. So we could step through, we could actually console log D, and then we can run it. Went through, let's run the solution. Anyways, so this is A, and this is D, which is basically A being this one, D being -4. So we have 3, next points to 2, which is next points to 0, which is next points to an object. What you don't see from just looking at A is that -4 points to next, which is 2, which is, and 2's next points to 0. 0 points back to -4. So it just keeps going in a circular way like this. That's what this little note here is. It's not a array, but yeah, it's just trying to let you know that it's a circular object. So cool. That's our first example. And then we have example 2, which is E and F. E being value 1, F being value 2, and then 1 points to 2, 2 points to 1, so it just goes into a giant circle again. And then when we run it, this is A from our first example, value 1, next, value 2, next, value 1, and then you would see next, value 2, and it just keeps going on and on forever. Cool. So just go down, and then we have G. G is the loneliest number. It doesn't point to anything. It has no friends. And so if we just look at it, it's by itself. Cool. So if we run through the solution, which you guys might have seen already, going through, this is true for example 1, true for example 2, and false for our third example. Basically what's happening is that we're passing in the head, which is basically just a node, and we have two variables, fast and slow. Example 1 is probably the best example to run through this. Slow. So while slow is true and fast is true, and fast.next, while there's a slow node, a fast node, and then there's always a node next from fast, while all these are true, we're going to say that slow is slow.next. So recursively, it's only stepping through one value at a time, right? And then our fast is going to skip. That wasn't a good skip. So our fast is going to skip a node every time, right? And it goes here, skips, goes here, skips, goes here. And so if our fast variable catches up, our fast variable equals our slow variable, then we're going to return true. If not, then it's not circular and we just return false. So we can run it, practice true, true, false, and then, yeah, same thing. You just go through here, run the code, run the test code, true, submit it. Waiting on the server, just judging us. And success. Cool. So that's our solution, YouTube. Like, comment, subscribe, and I'll see you guys in the next video.